Hey guys, today we're going to see majority element, which is a commonly asked problem in many companies. So it's an easy problem actually. So given an array of size n, find the majority element. Majority element is the element that appears more than n by 2 times. And we assume that the array is non-empty and the majority element always exists in the array. For example, an array 3 to 3, 3 occurs more than twice of the number of elements, more than n by 2 of the elements. So number of elements in this array is 3, n by 2 is going to be 1, and 3 occurs greater than 1 time. So which means 3 is our majority element. And when you consider this array 2, 2, 1, 1, 1, 2, 2, then in this array you see that 2 is occurring more times. So this algorithm basically, and this problem basically is an application of Barmore voting algorithm. So what is that is, given, let's take the second example. I'll explain that here. So you have element 2, 2, 1, 1, 1, 2, and 2. So this algorithm, Barmore voting algorithm, what it does is it basically looks at a particular candidate, which is the particular element under consideration, and checks whether the candidate element that we've chosen so far is equal to the number. And observe the candidate is equal to the current number under inspection, that will increment the count. And if count is 0, that means we have not got a candidate so far. So initially what happens is candidate is null. So as soon as you see a number, then you assign it as the candidate and see whether that number is our majority element. So as soon as we see another 2, we see that it is equal to the majority candidate that we assigned earlier. Okay, so which means we'll increment count. As soon as we see a number which is not equal to the candidate that we have seen so far, then we'll decrement it. Okay, and so on and so forth. So for example, so initially our candidate is empty, null, and we are encountering 2, so which means count is 0, right? Count is also 0. We do not have any candidate, it is null. So what we can do is we can assign 2 as our candidate, and we can check if candidate equal to the current element. If so, we'll increment count as 1 after assignment of a candidate. So now we are at this position. We see that this candidate is equal to a number, right? So which means we'll increment our count. So count is actually 2. Current number is equal to a candidate, and now we see 1 is not equal to a candidate 2, so which means we'll decrement the count. Okay, and come here, and 1 is again not equal to a candidate 2, which means we'll decrement the count. And now we are at here, and now count is 0, and which means that we have to assign this as the current element as the candidate, so our candidate becomes 1. Okay, and so it is the current count actually becomes 1 because the current element is equal to a candidate. And now we see 2. 2 is a number which is not equal to our candidates, which means the count will get decremented to 0. And then we see 2. 2 is not equal to our candidate, but then count has become 0. So this means 2 will become a candidate. So candidate becomes 2, and we have exhausted our search, so which means we should return the candidate as our majority element. So the majority element is 2, which is the output. Okay, let's look at the other example given as well. So you have 3, 2, and 3. So what you will do is initially count is 0, right? And then the candidate is also 0 initially. So null. So once you iterate over the array, you see that count is 0, which means we will assign 3 as our candidate. Okay, and then count also gets incremented to 1 because the current element is equal to a candidate. And then when we go to 2, we see that it is not equal to a candidate, so it becomes 0. Okay, and we see 3, and we see that a candidate is equal to the current number, and the count gets incremented, and basically count is 0. You can just say count is 0, so we're encountering a new candidate. We can take it as this well, otherwise we are seeing this candidate element is equal to the current candidate elements count actually becomes 1. So we'll return the candidate element because we have gone until the end of the array, and so the candidate becomes 3. Okay, so hope it was clear. So we will go ahead and code this program. So let's have integer candidate equals null. Let's have a count variable which is initialized to 0, and for int element and nums. Okay, now we'll see if count is equal to 0, which means that you're encountering the candidate, right? So we'll do candidate is nothing but the element. Okay, however, if we are encountering a candidate which is the current number, then we'll increment count plus is equal to else count minus equal to. Okay, once we do this at the end of the loop, what we're going to do is we're going to return candidate. Okay, so let me explain that again. So you have 3, 2 and 3, and so initially count is 0, candidate is 0, we're iterating of the element, and element current element is 3, so count is 0, so we'll assign candidate equal to candidate becomes 3. Okay, and candidate is equal to the current element. This is element because we are iterating over element. Okay, so we will increment count, so count is actually 1. Yeah, and so we'll continue the iteration. We say element 2 and we say count is not 0, and is candidate equal to element? No, it's not, so we count minus equal to 1, so count becomes 0. Okay, now we are at 3 and we see that count is equal to 0, which means candidate is 3. Well, we can just override this, and if candidate equal to element, then count plus equal to 1, so count is 1, and we see we have come out of the loop, so we'll return the candidate just 3, just the answer. Okay, and in the space complexity, we are not using any extra space, so it is O of 1. And when you look at the time complexity, we're just iterating over the nums if you were looking for the candidate, so it is going to be O of n. Okay, let's quickly run this code. Semicolon as expected. It's accepted. Let's submit this. Yeah, and it's a successful submission. So that's it, guys. Hope you like it. Bye.